My dear students, let me welcome you on behalf of this e-learning class. As per our the discussions on the magnetic effect of the current or the moving charges and the magnetism in the part number 3, we have to discuss what we already left as per our the last discussions. So, if you will recapitulate that one, the magnetic effect of the current means when the current will pass through the conductor, it will produce the magnetic field, and that magnetic field which it will produce, it will expressed in its the different forms as we know as per our the last classes. So, in the first class we have find what is the expression of the force due to the charge flow, what is the expression of the force due to the current motion, what is the Biot-Savart law, and its the applications. About that one we discussed. And before to that one, you also know as per your the syllabi the electrostatic chapter, in which it deals with your the charges at the rest. So, when the charges are the rest, if the charges are of the positive or one is the negative, another one is the positive, or both are your the negative, what type of the force they will exhibit, that was given by your the Coulomb. And the advanced form of the Coulomb's law, as we know, that is your the Gauss law. And regarding that way, we will now going to discuss the different two things. One is your the Biot-Savart law, which is equivalent with your the Coulomb's law. In case of the Coulomb's law, we are going to find what is the expression of the force, and you know that F is equals to your the K Q1 Q2 by your the R square. That provides the expression of the force either in its the scalar form or in its the vector form. Similarly, in your the Biot-Savart law, if the current will pass through your the conductor, then it will produce your the magnetic field. And what is the expression of that magnetic field, that we came to know. But also we know that if the advanced form of the Coulomb's law is your the Gauss law, and that Gauss law is applicable for your the surface area, in which we have to taken the Gaussian surface as your the cylindrical one or the spherical one, and here also we will take its the advanced form of your the Biot-Savart law, which is your the Ampere's law. So, today's main discussion we have to know what is your the Ampere's law. So, the today's lesson plans, as I said, that we have to discuss the two things: Ampere's law with its the application and the force between your the parallel currents. So, this Ampere's law, which will provide you the expression of your the magnetic field. Magnetic field due to the current flow or current carrying conductor. In the current carrying conductor, and this is known as your the Ampere's law. And this Ampere's law is your the cousin brother of your the Gauss law. As per your the Gauss law, we have taken the surface area, but for your the Ampere's law, we have to taken the length element. So, when the surface area is taken into consideration, suppose the surface area you will taken into consideration, that is taken in your the SOM books, that is the dA or your the ds, and with it is the electric field, and electric field E dot of your the dA, that is your the integration. Though this is your the area, means that is your the surface area which is a single integration, or instead of giving S, if you will give you the double integration, then that is equals to your the epsilon 0 by your the q, that is your the mu 0 by your the q, as we know that is the epsilon 0 by your the q. So, 1 by q times of your the epsilon 0, and that epsilon 0 which we discussed, that is derived from the value of the k, that is your the 1 by 4 pi epsilon 0 is equals to k we have taken here. But for your the Ampere's law, suppose you will taken a loop, we will take a current loop through which the current to be your the flow. So if we take the current loop and some, suppose this is your the current flow I1, I2 or the I3, and if we take the small element of that one, suppose this element is your the dl, then according to your the Ampere's law, it states that the line integration of your the B means your the magnetic induction. As we know that when the current will flow through your the conductor, it will produce your the magnetic field. So B vector dot of your the dl vector is equals to your the mu 0 of summation of your the I. So mu 0 with summation of I means that is your the mu 0 times the net current which is flowing through it. So the Ampere's law states that the line integration of B vector with your the dl dot product means the magnetic induction associated with your the closed element taken into account is equals to mu 0 times of your the total current which is present inside the closed surface, and that can also be written mu 0 of your the current inside the net current which is inside your the conductor, that one is it's the known as your the Ampere's law. So what is the resemblance between these two? You observe the, this is your the surface integration, this is your the line integration, this is your the dot product, this is also your the dot product. It provides due to your the current, therefore this is your the epsilon, and though this is due to your the magnetic field, that is your the mu 0. So this is your the mu 0 of your the summation of the I. So next one is, what are its the valuable points to be noted? Valuable points to be noted. The first point is, this magnetic induction which we have to find, that is only observed due to the flow of the current. So what type of the current we have to take into account? The first one is, the current should be steady one. The current should be steady. So what do you mean by the steady current? Means no change in its value, that is your the steady current. And the second one is, the magnetic induction or the magnetic field, that is your the B, is your the non-zero, then it is tangential to the element, that is your the non-zero tangential element, also constant, So this B value, that must be your the either it is your the constant, though B vector dot dl, if you expand that one, then this is the dot product, means B dl cos of angle between your the B and your the dl. B means your the magnetic induction, dl means your the length, vector length, and that two what angles it makes, that is of the integration of B dl cos theta is equals to your the mu 0 I inside. So now the question comes, what is your the theta? Theta is the angle between the B and L. So what it states? The magnetic field is your the non-zero, it must be your the non-zero one, either it is a non-zero or it is the constant. If it is the non-zero, means it has the some value. So dl is the length we are taking into consideration, theta is the angle, and for most of the cases the angle means the angle between dl and your the B, that must be your the tangential. So how that magnetic induction we have to take in for this one? So to find its the magnetic induction, as we know that suppose the current is flowing in your the clockwise direction. So the direction in which the current is flowing, you have to curl your the right hand's 4 fingers. So these 4 fingers to be the curl, the 4 fingers and the thumb, they should be perpendicular to each other. So when you are curled to this one, then you see that this thumb is pointed inward, means the current is directing in this direction. So when the current is directing in this direction, the field is likewise. Suppose this is your the length, then if you rotate this one, the current is in this direction, means the magnetic induction for this one, that is equals to the in this way. Suppose you will take the another DL one, means this is the current flow, means the DL will be the likewise, means this is your the B, and if the small element is here and this is your the B vector. So this B and your the DL, they are the tangential here. So if it is the tangential, means theta is equals to the 0 degree. So if theta is equals to 0, means cos 0 is equals to your the 1. So that is equals to integration of the B DL is equals to mu 0 I inside. So if inside the current here, what we have taken, here we have to taken the 3 currents. So instead of taking the 3 currents, you can take your the 1 current or the 4 currents, but here they are in the same direction. And as per your the value point tables, the current moving out of surface is positive and moving on the surface is negative. So you see here, these 3 currents, they are going out of the surface. So inside they are going out, means they are of here the positive. So if instead of taking these 3 currents, if one current is in this direction, means it is your the going out in the opposite one. So if it is out, means it is in the in. So in this case, the total current inside, that is the sum of these 3. So this inside one will be the mu 0 I1 plus I2 plus I3, if the 3 are in the same direction. If anyone is in the opposite direction, according to this figure, I3 is in the opposite direction. So I3 if in opposite direction, means it is the minus. So I1 plus I2 minus I3, whatever it may be, it will give you the net current. So that is equals to the mu 0 of the net current is equals to the I, which is present inside that one. So here another thing we have to consider, that if the currents are here, instead of the currents taking inside, suppose some current is present here and another current is here there. So this is I1, I2, I3. Suppose I will take this is your the I4 and this is your the I5. So these I4 and the I5, though the current is flowing, it produces here the magnetic field. So the magnetic field due to I1, I2, I3, I4 and I5, they to be taken into account. But the net current which is inside that one, only that to be taken into account. So if these 3 currents and these 2 currents all are to be taken together, due to the current affects magnetic field, for the magnetic field, all these 5 currents to be taken into account. But if you take the current only for your the law, you have to take in the current inside your the conductor only. So for this one, the BDL, so this BDL means if B is equals to the constant, you see at every position if the B to be the constant, that constant will comes out, then that is equals to the integration of the DL. So integration of the DL is what? Integration of the DL will give you the total length of that conductor. So by taking, if this is your the one type of the loop, suppose I will take a loop of your the circular in shape. Suppose we will take a circular in shape. Suppose the circular in shape, this is its the center, this is of the radius of the r. Suppose the current is moving in this direction. Here I have taken in the anti-clockwise, but before we have taken in the clockwise direction. So if it is near the clockwise here, means the current will out, it will comes out, but there it is in the in. So when it is your the out, that currents are your the like this symbol with your the dot. This is the current. Suppose you will take the small element. So small element means this is the current direction. So the current is going in this direction and you have to rotate this one. Means it is coming in the opposite one. So whatever it may be, if this is your the B and this is the DL, means here the integration of the B vector dot DL is equals to your the B DL cos theta, that is equals to your the B dl of cos 0, that is equals to your the B dl. Though this is the circular, the point distance at from its the center always remains here the same. So the B value is the constant as we have written in the valuable points. B will comes out, then integration of the dl. So what is this integration of the dl? This integration of the dl is the total length of this circumference. So though we have taken its the radius as your the r, then this b dl will be your the 2 pi r. So this is your the integration of the b dot dl, and according to your the Ampere's law, this integration of the b dl is equals to mu 0 of your the I inside. So this is equals to your the 2 pi r b is equals to mu 0 I inside. From where we can find the value of the b. So with this we came to the conclusion that for the Ampere's law, it is the analogous to that of your the Gauss law. As we discussed, the Ampere's law, which states that the line integral of your the closed current carrying conductor's circuit is equals to your the mu 0 times your the net current present inside that one. As we know about your the Gauss law, then we have discussed the applications of the Gauss law for the various cases. Similarly, according to the syllabus, we came to know that what is your the Ampere's law and its the application for your the different cases. For the application of the different cases, one is your the due to your the straight infinite length of the current carrying conductor, one is due to your the solenoid, and third one is due to your the toroid. And about your the straight current carrying conductor, about the solenoid, and about your the toroid, we also discussed in your the last classes what will be its the magnetic induction. Though it is its the advanced form, the basic concept will remain here the same. Means what the mathematical expression we already obtained before by using the Biot and Savart law for these cases, that we have to derive by using your the Ampere's law. So let us now come to apply the Ampere's law for your the straight current carrying conductor. Means application of Ampere's law. Number one is your the magnetic induction or magnetic field due to an infinite straight current carrying conductor. So as we discussed earlier, for your the straight current carrying conductor, the B is equals to your the, for your the finite length, we derive mu 0 I by 2 pi r of cos phi 1 minus cos phi 2. That is for your the circular straight current carrying conductor, B value we came to know. For the straight, for your the solenoid. But for your the straight current carrying conductor, this B is equals to your the mu 0 I by your the 2 pi r. So if that thing to be your the apply for your the Ampere's law, we have taken this is your the straight current carrying conductor this is your the infinite side, this is your the infinite. Though we have taken the infinite straight current carrying conductor, say the current is going in this direction. We are interested to find the magnetic field at a point. Let this is the point P, which is at a distance of your the R. To find the magnetic field or the magnetic induction by applying the Ampere's law, we have to take in a Ampere's loop. Means by taking the point P, we have to take in an Ampere's loop. So this is called here the Ampere's loop. Means some current to bear the flow. Let the current is flowing in this direction, we have seen. So though this is the current which is flowing, means the current to bear the present here. So if the current means, suppose this is your the straight current carrying conductor, this is the point P where we have to determine the magnetic induction. If we will take here the top view of that one, means if this is the current carrying conductor and we have taken the Ampere's loop, the current is coming out of that one, and if you will take this one, so what is your the direction of the current? Means by putting this your the right hand side, you have to rotate, means it to be your the move, means it is in this direction. Suppose you will take the small element, here it will be the tangential, and if we take the small element, it will be the tangential. If we take the small element, it will be the out. So means this small element means B vector dot dl is equals to your the mu 0 I, as we have seen for your the Ampere's law. So this B dot dl means B dl cos theta is equals to your the mu 0 I. So this integration. So this B is the constant, because the distance from its the conductor is always here the remain same. So B is the constant, comes out. Cos theta means from the dl and here the B, though we have taken in the anti-clockwise direction, this will be your the B, this is your the dl. Suppose the small element is here, here it is the tangential, this is the B, this is your the dl. So B dl, B dl, B dl at every point, that is your the 0. So this B dl cos theta means cos theta is equals to cos 0 is equals to your the 1. So that is equals to integration of dl is equals to your the mu 0 I. Implies B is the constant, integration of dl is equals to your the mu 0 I, implies B integration of your the dl, means by taking the small element of all these. So dl integration will be your the total length. What is the total length of this loop? That is equals to its the circumference. That circumference is equals to your the 2 pi r is equals to your the mu 0 I. So we are interested to find the magnetic field, means only B. B is equals to mu 0 I by your the 2 pi r. B is equals to mu 0 I by 2 pi r. As per we have discussed earlier classes, B is equals to mu 0 I by your the 2 pi r. So this is your the magnetic induction due to your the straight infinite length of a current carrying conductor by putting your the Ampere's law. This is for its the first application. And if we will go for its the second application, that is your the solenoid. So what is your the solenoid? A solenoid is a cylindrical shape. It is your the cylindrical shape over which a coil to be your the wounded. Over which a coil to be your the wounded. Suppose the current is flowing, we are interested to find your the magnetic induction at this point. Suppose you have to find the magnetic induction at this point. We have taken a current loop. As I have said that the current loop is either of your the circular shape or of your the rectangular or of the square. So here we have taken, this is the point P, let it is your the A, B, C, D. So, though this is the cylindrical one, let the current is flowing in this direction here, and the current is your the I, means the integration of B dot dl is equals to your the mu 0 I. So, here the B dot dl of your the total one means the closed integral of this one. So, this closed integral means of A, B, C, D, that is either putting this one, if we write A, B, C, D, B dl is equals to your the mu 0 I. This implies integration of the B vector dot dl, B vector dot dl plus integration of B vector dot dl plus integration of B vector dot dl plus integration of B vector dot dl is equals to the mu 0 I which is your the inside one. So, this is your the I inside. So, here there are the 4 factors. How that 4 factors being came? You see A, B, C, D, if the total one is to be divided for your the 4 arms of the AB, BC, CD and DA. So, this is the BDL means your the through AB1 integration, this is your the BC, this is your the CD, this is your the AD is equals to your the mu 0 of your the I inside. If we will go for your the AB, you see AB, the current is going in this direction, the magnetic field is also in the same direction. So, this B dot dl means what will happen for its the cos theta factor. So, cos theta means this is your the in this direction, the current is going in this way. In this way current will means the angle is equals to the theta, this cos theta, this theta is equals to the 90, that will your the vanish. For your the BC, if you will observe for your the BC, what will happen? This factor is out of your the surface. So, out of the surface there is no magnetic field. So, here the magnetic field B is equals to the 0. So, this factor will be your the 0. This cos 90 factor, that will be your the 0. Then remain your the of CD. If you will go for your the CD, that is completely to be your the 0, and this will be your the DAD. So, that factor will be your the in the same direction. If you will take, then only the out of these 4, only one factor to be your the remain, that is the BDL is equals to your the mu 0 of your the I. So, this B of the total length of your the DL, if we take a DL means this is its the only length one. So, this is equals to the BL is equals to the mu 0 I. So, I is what? I is your the net current. So, we have taken the net current means if the current N is the number of turns per length, number of turns per length, then what will happen for your the total length of your the L for the 1. So, total length is equals to the NL. So, NL is the number of turns of the length, and the current through your the each turn is equals to your the I. So, NLI is equals to your the total current. So, the net current inside means the net current I is equals to your the mu 0 of your the NL of your the I. So, now this N, this L with the this L cancel. So, this is equals to B is equals to your the mu 0 Ni. So, this B is equals to mu 0 Ni. If you put this value, you will obtain for your the solenoid B is equals to mu 0 Ni as we discussed earlier. So, with this, that is your the application for your the solenoid. Similarly, you will go for your the toroid for the circular shape on the same way. Now, we are going to discuss about a law's applications with the invention of your the some new things. As per our the last, we came to know about my name law, that is your the Ampere's my name law. So, that Ampere's my name law is known as your the Ampere's circuital law. So, some joke we will make here, that is Ampere's circuital law. Circuital law, which states that integration of the B dot dl is equals to the mu 0 I inside. So, this Ampere's, I said that Ampere's my name's law. So, that is your the circuital. So, if you take in the joke way, circuital. So, this is your the sir, CIR, sir means myself, and here the quital. So, my name is also the key to. So that is your the circuital. So Sarm yourself law, Sar's law means B vector dot dl is equals to mu 0 I. By taking this concept into the account with the assistance of the another one, that is your the force experienced is equals to your the BIL sin theta, as we know. And for its the maximization, F max is equals to your the BIL, that we came to know in our the lecture number 2. So by taking this concept into account with here the B is equals to mu 0 I by your the 2 pi r, as we derive in this class, that the magnetic induction due to an infinite length straight current carrying conductor, either by putting your the Biot-Savart law or by putting your the Ampere's law, B is equals to mu 0 I by your the 2 pi r. By putting these two concepts into account, we are going to find the force between two parallel current carrying conductor. Force between two parallel current carrying conductor. So the force between two parallel current carrying conductor, either of the finite or of the infinite. Here we have taken here the two infinite straight current carrying conductor, for which we came to know that B is equals to mu 0 I by 2 pi r. Let the distance between them is your the d, and the current which is flowing through them is your the I. If we take the two conductor as your the 1 and your the 2, so here the current is I1, here the current is your the I2. So though if we take for your the second conductor, for second conductor, though this is the infinite one, that is the one case, or for your the finite one, from that one we will derive the same one. So if I1 and I2 be the current for the second conductor, if we consider, and they are separated through the distance of the d, though this is your the first conductor through which the current is your the flowing. If the current is flowing in this direction means, and the current is also flowing in the same direction, so here the force between two parallel currents, though they are moving in the same direction, we have taken it is your the parallel current. So here the question comes, sir, if it is your the anti-parallel current, means out of these two, either I1 to be the reverse, I2 to be remain same, or I2 to be the reverse, keeping your the I1 to be the same, then what will happen? For that case we also discuss. So I1 and your the I2. So if you consider for your the second one, these two be the affected by the influence of your the first one. Means though the force we have said, force between the two, means though the two conductors we have taken, the force to be exist means this must to be the influence to its region, and this current must influence to this region. So if the force to be the exist means, due to your the first conductor, it will produce your the magnetic field, as we know earlier. If the current will pass through your the conductor, it will produce your the magnetic field. So for the second one, if you will consider, this is your the so the magnetic field to be created by your the first conductor, and that to be affected by your the second one. So when the second one to be your the there, and it is inside your the magnetic field, and you know that if a current is flowing through a conductor which is placed in a magnetic field, the force experienced F is equals to your the BIL sin theta. BIL of your the sine theta. So here the force to be your the maximization, that is equals to theta. Theta is the angle between your the B and your the DL. Though this is your the current is flowing, and if the current is flowing, it means what will be, see the B1. So if the current to be in the thumb direction, these four fingers will give you the value of its the magnetic induction or the magnetic field, and if this one, and it is going likewise. So it will come in this way, means it is tangential to that one. So though this is the circular in shape and this is the tangential, the angle which to be the incline, that is your the 90. So F is equals to your the BIL sine theta, means F maximization is equals to your the BIL. For the second conductor, means this is the F force due to your the second conductor by the influence of the one, F21 is equals to your the B. B means is what? The magnetic induction. So this is the force due to the magnetic induction of the first one. So this is the first one, the magnetic induction which it produces, if that is equals to your the B1, not Bx, we have taken here the 1. So this is equals to your the B1. So I means your the current which is flowing in the second conductor, that is the I2. This is your the I2 of your the L. L is its the length. So this implies F21 is equals to B. B means what? Magnetic induction. As we have written, the magnetic induction due to the straight current carrying conductor is equals to mu 0 I by your the 2 pi R. R is what? R is the distance from where the magnetic induction is going to be the calculated. So you see, this is the second conductor, but the influence due to your the this one. So this current I2 will be your the how one? This is equals to your the B. B will be your the how one? That is equals to mu 0 I. I means due to your the this one, the magnetic induction is produces. The current is your the I1. So B1 is equals to mu 0 I1 by 2 pi R. 2 pi R means the distance. Here we have taken that is the D. So 2 pi D of your the L, means F21 by L is equals to mu 0 I by your the 2 pi D. This is the force per unit length is equals to mu 0 I by your the 2 pi D, force per unit length. So if this is the force, here you see the notations which I have taken 2 1. In some way you can take that is the 1 2, but the saying of the mode is different, but the most concept is the same. Because if you write 1 2 means the force due to your the conductor 1 which is influenced by your the 2, and here the F21 means the force on your the second conductor due to your the first one, but the concept is your the same. So either you will take F21, according to that you have to write, F12 you have to write, but the expression will be the this one. But now the question is, what is the direction of your the force? The direction of the force is to be determined by your the right hand palm rule. That is the right hand palm rule, means this is on the right hand, the thumb and the four fingers, they to be placed in the perpendicular to each other. You see, the current is going in this direction, and this is the four fingers. The current and the four fingers, that to be the curl. So if this is the force and this one, means what is, this is the current direction and this is your the four fingers, where the palm is remaining, the palm is directed in this direction. So this is the current, this is the palm. The current is going in this direction, means the palm is directed towards me, means this is your the F21. That is your the force due to your the second conductor on your the first. And if we go in the reverse way for your the first conductor, for first conductor, for the first conductor, the same way F is equals to your the BIL sine theta, F max will be that one, means the force on your the due to your the first on your the second, means how this one will be. So this conductor is influenced due to your the this one, means this is its the magnetic field. Within that magnetic field, this conductor is passing. So, through a magnetic field, when a conductor to be the placed, according to the formula, the force which it will exhibit, that is equals to the BIL sin theta, or the force maximum is equals to the BIL. That is equals to the BIL, force maximum. But here I have written F12 means on your the 1 due to your the 2. So, F12 is equals to the BIL. So, this B means the magnetic induction, that magnetic induction due to your the second one. The second one magnetic induction is equals to the B2. So, here it is your the B2, I is your the current due to your the this one. So, this one is equals to your the I1 due to the first one, that is the I1 of your the L. So, this is equals to B2, B2 means the magnetic induction, mu 0 I by your the 2 pi r. So, mu 0 I B2, B2 is the this magnetic field. So, the current is your the I2. So, mu 0 I means mu 0 I2 by 2 pi r, r means your the distance from the second conductor to the first conductor, the distance is your the d. So, d of your the L, then I1 is here, I1. This is the B2, I1 is I1, L is L. Means F12 by L is equals to mu 0 I1 I2 by your the 2 pi d. So, F21 by L is equals to this one, F12 by L is equals to this one, means the net force per unit length is equals to this one. So, if you have taken the infinite length and you will take its the finite size, we have taken a small length of that one, for which we have taken the length is your the L. Therefore, that is equals to the F by L. On looking these two, what difference you are observing? No difference, this force and this force, but this force is acting in this direction, and what will happen for this one? This force will act in this direction, means they will attract to each other. So, if the current is flowing in this direction, you see, if the current is flowing means the current is in this direction, the four fingers where the palm is your the indicating, you see, if the current is going in the upward direction, as we have taken the current flow is in the upward direction. So, to that upward direction the thumb is there, the four fingers are in this direction, and where this thumb is, the palm is remaining, the palm is remaining towards me, means the palm is in this direction. So, that is the direction of the force. So, the F12, this is the direction of the force, F21 is the direction of the force. So, what conclusion we obtained now? That conclusion is these two forces are your the attract each other. So, the force between two parallel current carrying conductor, they will exhibit a force, that force is attractive in nature. Hence, the force is attractive in nature. If the current is flowing in near the anti-parallel current is flowing. So, if this is one direction, this is the opposite direction, then that will be near the repulsive one. The force is repulsive for anti-parallel Maimausi Khuripiusi current. That is your the Maimausi Khuripiusi, they are all known as the anti. So, anti-parallel current, the force is your the repulsive. Means, if the currents are in this direction, that is your the attractive. If they are in the opposite direction, they are your the repulsive. Not taking in the parallel way, if we take in the making certain angles, suppose likewise the conductors we have taken, they are going in this direction, the currents are going, means they are your the attractive. Similarly, if we draw the figure, likewise, one is in the this direction, this is in the another direction, then this is in the another direction, that is your the repulsive. So, what conclusion we drawn from this analysis? If the current is flowing in the same direction, then the force which they will exhibit of the magnetic nature, that is the attractive. If they are acting in the opposite direction, then the force is the repulsive. So, this is the conclusion about the force between the two parallel infinite length or the finite length current carrying conductor, and their force expression is mu 0 I by the 2 pi d. I have taken d or the r, whatever you will take. As we came to know that when the current is flowing through the two parallel conductor, either in the same direction or the different direction, the force which they will exhibit either attractive or the repulsive, and that amount of the force per its the unit length is equals to mu 0 I1 I2 by the 2 pi d. So, by taking that expression as it is the fundamental, now we have to derive what is the definition of the ampere. So, the force per length is equals to mu 0 I1 I2 by the 2 pi d. This expression we already derived. So, this is the force per unit length. If the length is the finite, then divided by that length, that is the force per unit length. If we have taken the infinite length current carrying conductor, we have to taken its the finite size. If that finite size is your L, either big L or the small l, whatever you will take, then the force per length is equals to this one. So, here I1 is equals to I2. If we will take, that is the 1 ampere, then d is equals to the 1 meter, then F by L is equals to the mu 0 1 into 1 by 2 pi into the 1. You see mu 0 I1 I2, I1 I2, if that is the 1 ampere, d is equals to the 1 meter, then your F by L is equals to mu 0 1 into 1 by the 2 pi into the 1. That implies F by L is equals to the mu 0 by the 2 pi. And if we multiplied by the 2 in the numerator and multiplied by the 2 in the denominator, there is no change in its the value. So, 2 is multiplied, here 2 is multiplied, means that is equals to the 2 mu 0 by the 4 pi. According to the Biot-Savart law, we know that the force constant, which is magnetic field constant K, that is equals to the mu 0 by 4 pi, that value is equals to the 10 to the power of minus 7. So, this is the force per length, means though this is taken in the ampere, though this is taken in the meter, they are in the m case. So, the force per length, that is also in the m case, means that is the Newton per meter. So, if the force per unit length is exhibit a force of either attraction or repulsion, that depends upon the nature of a flow of the current, then the distance of separation between them is the 1 meter. If I1 and I2, at that case is the 1 ampere. So, in this way we have to write definition of ampere. Definition of the ampere means the current is said to be 1 ampere. The current is said to be 1 ampere each in every conductor when they separated through a distance of 1 meter and produces the force of attraction or repulsion of a 2 into 10 to the power of minus 7 Newton by meter. When this force per length is 2 into 10 to the power of minus 7 Newton by meter, you see 10 to the power of minus 7, what a small value of this one. Means if the two conductors are separated through a distance of, suppose this is equals to the 1 meter, the current either it is flowing in the same direction or the current is flowing in the different direction, they will exhibit a force. For your the same direction, this force is your the attractive. This force is your the attractive. This attractive means the when the term of the attraction is comes, means we are thinking that one will come and make join with that one. So that is not actually happen. You see 10 to the power minus 7. 10 to the power minus 7, it is a very small value. But they will show that that force is attractive in nature. Attractive in nature means they are in this direction. So by this way we can define the definition of your the ampere. So by taking this definition of the ampere and the expression of the F by L, we have to make its the use. And for the use of the students for yourself, it is very important in your the coming examinations like your the state board or the central board or of your the in so much of the competitive examinations. So in the competitive examinations, the students they are fearing that how I will appear for the competitive examination, because so many of the problems it will come. So I have not gone through the problems easily. So how I will solve that one and how a good mark I will secure. But I have said in my class that if you go through my Pandava formula, you can get the solution of your the every problematics one. And that Pandava formula means it has its the 5 steps, that is its the Pandava formula. So that 5 steps means the first step you go through the question and understand its meaning. प्रश्नर उत्तर प्रश्नटी को पढ़िबा एवं तार अर्थ बुझिबा. Go through the question and understand its meaning. Second one is your the if a problem is there means something must be given, means they are your the data. Some data are provided, write that data. The third step is after giving the data it will ask something, means something to be your the asking. That asking one will put in your the question mark. The fourth one is सबसे बड़ा खिलाड़ी. This step is the most important one, means all the systems are in the same unit or not. You have to convert if they are not in the same unit. And the last one is the put the formula, get the answer. By taking these steps we can go to solve your the different types of the problem. Let us now look, there is a problem on your the screen. So what that problem is given? That problem is two parallel current conductors AB and CD. Two conductors AB and CD of length 30 centimeter apart. So their distance of separation is your the 30 centimeter apart. Carry a current of the 10 ampere and the 15 ampere. Suppose one is your the 10 ampere, one is your the 15 ampere. 10 ampere and the 15 ampere respectively in the same direction. It is given in here the same direction. So what it shows? Same direction means they are the attractive. Find the magnetic force acting over the length of your the 5 meter. So for the 5 meter, what will be? It's the problems magnetic force we have to find. So according to the formula, first one the question, the second one is the data. What are the data they are given? You see this is the 10 ampere, that is the 15 ampere, means one is the I1. I1 is your the 10 ampere, I2 is your the 15 ampere. Next one the separation is your the D, D is your the 30 centimeter. These are your the given. The fourth one is, third one is the asking. What is asking? Find the force. So force we have to find. Next one is the what is its the nature. Force is this and nature is equals to what? but the fourth step is the put they are must be in your the same unit. So if they are in the same unit, you see ampere, it is in the m case, this is the ampere in the m case, you see this is your the centimeter, means this is in the CGS. The fourth step is all should be in the same unit. These two are in the m case, this is in the CGS. So this is CGS to be converted into the m case. Though this is the centimeter, in the m case that should be in the meter. So that 30 centimeter to be your the meter means divided by the 100, 0 0 is cancelled. So 0.3 meter. So D is equals to the 0.3 meter. What is asking? The force. You see what is our the formula? The force per unit length. Force per unit length is mu 0 I1 I2 by your the 2 pi d. So force per length is equals to mu 0 into I1. I1 is equals to the 10 into I2. I2 is equals to the 15 by 2 pi d. 2 pi d. 2 into pi into d. D is how much? 30 centimeter. 30 centimeter is equals to the 0.3. So we have to solve this one. So if this is the mu 0 by 4 pi, so let us now multiply it by 2. 2 into 300, 15 into 10, 15 into 10, 150 into 2 is equals to 300. That is the mu 0. So we multiplied by the 2, that is equals to 4 pi into 0.3. So 0.3 means mu 0 by 4 pi is equals to 10 to the power of minus 7 into your the 0.3 means this is the 3 by your the 10. So 3 into 10 to the power of the 3 by 10 means 3 into 10 to the power of 4. So minus 7 of the 4, that is equals to 10 to the power of minus 3 into your the 3. That is the force per length. But what is the question is asking? For your the 5 meter. Though this is the per unit one, for the 5 meter you have to multiply it by your the 5. That is the net force on it. So you will give me the comment if 3 conductors are there, then if A, B and the C, find force on B. This is the first one. For the second one, if the 3 conductors are there, A, B, C, just the current direction is the different, find force on C. So these two things you try in your the home and give me the comments. Thank you very much.